Alright, so I wanted to give you guys an example of a projectile that has an initial velocity only in the x direction, or horizontal initial velocity. Okay, now this type of problem takes into some background information. Okay, one, we need to know how far it's going to be going. Okay, so for this one, we're going to say that we have an object on a 20-meter tall cliff, and let's say there's a person playing soccer, and this guy kicks the ball perfectly horizontally so that when it leaves the edge of the cliff, its velocity in the x direction is 10 meters per second. Now, what we want to know, I'm going to say I want to know what the range is. And so that would describe how far this object would go in the air in projectile motion. So this bar that I just made represents the range. Okay, now our last video talked about range, talked about vertical components and horizontal components and things like that. So we know from that our delta x, and it's delta x because that's changing this, delta x, is going to be equal to the velocity in the x direction times the time. And so you guys will notice that we're already given our velocity in the x direction, but we need to figure out how long it's going to take to get to the ground. Now again, our last video also talked about how if I drop an object or fire it perfectly horizontally, like this figure shows, dropped, fired horizontally, they're going to hit the ground at the same time. Okay, now they won't hit the ground in the same place because one has a horizontal component of velocity, but they'll hit the ground at the same time. And so for me to figure out how far this needs, I need a time. Okay. Typically speaking, the strategy when solving these is to first find TOF. TOF stands for time of flight. Okay, once you can find the time of flight, after that you can solve for any other piece. In this case it would be to find our range. So this is x, this is y. Now, if this is only in the x direction, that means that my vi in the y is also, well, is not also, but it is 0. Okay, because all of this velocity component is in the direction of the x direction, excuse me. So therefore, our velocity initial is only in the y direction. So that allows me to do some things. Okay, I know that number right there is my delta y because it's going to start here and it's going to end there. But again, when I do delta y, I also need to know that it's in the negative direction. So my delta y is equal to negative 20 meters. Okay, by the way, this is my no column. Okay. I also know one more thing, and it's implied. Again, this object, just like we showed with that figure, it's acted on, and the only force acting on it is gravity, and therefore the acceleration of gravity is negative 9.8 meters per second squared. So if I want to figure out what the time of flight is, I'm going to use this equation. My delta y is equal to vi yt plus 1/2 negative 9.8 t squared. We know that this is 0 because our vi and the y is 0. We know that this is 10, negative 20, excuse me. And so using that, we get negative 20 meters. It's going to be equal to 1/2 times negative 9.8 meters per second squared times my time squared. Solving for that, I'm going to go ahead and we get negative 4.9 on this side times t squared, negative 20. And I get 2.02 for my time, so 2.02 seconds. Okay, well now, again, like the last video that said, we can go between vertical and horizontal components using time. So I have a time, I can then take this and I can insert it into that equation, and I can also take this and insert it into that equation to be able to figure out what my delta x is. Delta x is going to be equal to my velocity in the x, 10 meters per second, times my time, which we just found in the y, but again, time is the same in the y and the x, times 2.02. So 10 times 2.02 gives me 20.2 meters. So in summary, again, remember that we can go from our vertical direction to our horizontal direction back and forth based off of the fact that time stays consistent between the two. Again, usually the strategy goes as follows: find the time of flight, and then after that you can find your range. Now things get a little more complicated when we get into an initial vertical component, but nonetheless, it still is something that you guys can do. It just takes a little more math. So there's your first projectile problem. Again, like always, email if you have questions. Otherwise, enjoy.